This is CS1101, lecture 11.1. We're beginning our discussion on objects. So as a reminder, an object is an encapsulation of data and behavior. So it's a way of combining both the data that we want to store and methods that we might want to apply to that data. This idea of an object leads to a type of programming called object-oriented programming, or commonly OOP. Object-oriented programming is an approach to writing code where most of the useful functionality of the code comes from interactions with objects. That'll become more clear as we begin to actually write a bit of OOP code, or object-oriented programming code. But basically, most of the functionality is going to come from the data stored in the object and the methods that are stored in the objects. We've already done a little bit of this object-oriented programming in that we've used object types such as string, scanner, file, and random. Each of these is a class that when we instantiate it makes an object, and we are able to make use of that object to get random numbers or process strings from the input or from a file or from another string. So we are able to accomplish most of the functionality that we were after by interacting with these objects. But up to now, we've not built our own objects. We've not written our own classes to define our own objects, and that's what we're about to change. So let's take a moment and understand why this idea of OOP and objects is so helpful and important. So imagine we were having to write a program that would be able to identify which cities were going to be affected by some earthquake. And all these cities are stored in an input file. And we're going to feed this input file into the program. And the program's going to say, of these cities, the following will be affected. The output might look something like this. So there's a city at X value 50, Y value 20, that'll be affected 90, 60, 10, 72. And there's a total of 6 cities that are affected by the earthquake. Then it'll also print out the epicenter of the earthquake. And the way that it decides if a city is going to be affected or not is if the city is within a distance of 75 from the epicenter of the earthquake, then it's affected. So each of these cities is within that radius of effect. As it stands, you probably are thinking, well, I could use a point object. Ah, yes, an object. But imagine if we didn't have objects. Imagine if there was no point object in Java. Then this would be significantly more difficult, because now you're going to have to read in from this file the cities, and you're going to have to store each X value in an array and store each Y value into an array. And then you'll have to write some program to process those two arrays, calculate the distance from these XY values to the epicenter, and then process all of the individual elements of the arrays and figure out, okay, here are the cities that are going to be affected. It's doable 100%. However, it's not very readable. If you think about how that code is actually going to look and how you have to actually write it, it's going to be ugly. It's going to be difficult to read, and it's going to be cumbersome to deal with. It's a lot easier to use objects. So the great thing about an object is it represents the idea, in this case, of an XY location. And it embodies the XY data as well as common behaviors associated with XY data, like finding the distance between two XY locations. So an object is a code representation of the idea of an XY location in this instance. That's what a point object is. It's a code embodiment of the idea of an XY location, as well as behaviors associated with XY locations. So with this point object, we can easily compare the distance between the epicenter point and the city point, because that's a behavior built into the object. We can easily convert it to a string so that we can print it. Think about that. If these were stored in arrays, you would have to write some custom print method, and that would again be simply cumbersome. Doable, yes. Cumbersome, yes. And not very readable and difficult to maintain, for sure. Using objects in this situation, and in most programming situations, is going to make the code easier to write, easier to read, and shorter. This is why it is important as a programmer to be able to use objects and write code that is object-oriented, because it allows you to write code more easily, so it's easier for the programmer initially. It's easier to also maintain. So writability, readability, and maintainability. So when we're talking about object-oriented code, there's typically a client program that makes use of and interacts with these objects. So we refer to it as a client program. Primarily thus far in the course, that's what you've written. You've written client programs. And these often look something like this. We'll have some class maybe called payroll, where we're going to, calculate, how much each person should be paid based on how many hours they've worked. And to do this, we need to be able to read from an input file and write to some output file. So we're going to need to make use of the scanner class. So we're going to have scanner objects in our program. We will probably make use of a print stream class so that we can write to our output file. So we'll have a print stream object in our program. Probably file objects as well, obviously, as well as others. And then the functionality that is built in this client program is going to be based on interacting with these objects. So there are the individual classes which implement objects, and then there's the client program that interacts with those objects. So we have client programs and we have the classes. So in this nomenclature, a class is going to be a program that is not executable, but rather represents a template for a specific type of object. As an example, think of the print stream class. So the print stream class is actually a Java file that was written by someone, and when we say in our program new print stream, what we're doing is we're saying, Java, we want you to go look at this class called print stream, and we want you to create an object based on the blueprint in this class file. So we'll be able to define our own classes and therefore our own objects that we can use in future client programs as well. So why would we want to do this? Well, let's say that we have to write some new class to create some object that we don't currently have. That's an investment in time in the short term, but long term, that's going to help us. So, for instance, the point class. Before the point class existed, each time someone needed to deal with XY data, they had to go about it in the cumbersome way we discussed previously. However, now that the point class exists, you don't have to re-implement that. You simply import the point class and make use of it. So yes, initially, it might have been faster for the person who wrote the point class to just write their program based on arrays. However, by putting in the extra time, they have now made it to where anytime they want to write a program dealing with XY data in the future, or anyone else wants to write a program dealing with XY data in the future, there is much less development time. So this is a big picture, long-term view that we take when we build objects for reuse. So here we're going to introduce a vocabulary word and qualify it. The word abstraction has a lot of different meanings. They're all somewhat related, but it's important to understand what we're talking about in object-oriented programming when we say that we are abstracting something or this is an abstraction. When we're talking about it from a programming perspective, abstraction refers to distancing an idea from the details. You've done this already by using the methods built into objects. You can use the hasNextInt method built into a scanner object without actually knowing how that method is implemented. You've never looked at it and you don't care what the code is as long as it works. So a lot of times this leads people to think of it almost like a black box. I don't know what it does inside and I don't care what it does inside as long as it tells me what I need to know, as long as it does what I need it to do. Imagine someone standing in a missile launch site, and a scientist who is responsible for building all of the very complicated launch system is there with someone who is just a bystander. And the scientist says, "Do you know how hard it is to launch a missile?" And the person says, "I thought I just had to push the button." The scientist is talking about the difficulty involved with building a launch control system and actually guiding the rocket, generating enough thrust to get it off the launch pad, all of these intricacies, where the individual who is unfamiliar with all of that difficulty is thinking about it from the abstraction, which is there's a button to push which launches the missile. So when we write objects, when we write these classes and build objects, we want to write our methods in such a way that they're abstracted so that the user of the object doesn't have to deal with the nuts and bolts and rather only has to deal with the abstracted idea of what that method is going to do, like char at or hasNextInt. We don't care how it does it, we only care that it does do it. It tells us if there is an nextInt, or it gives us the char value at a specific index. I'll introduce one more example so that we can use it as a template for discussing objects a little bit further. Most people know how to use an iPhone. They understand the screen, they understand that it has a touch screen, and they understand how to interact with apps. However, very few people understand the actual inner workings of the iPhone. And it wouldn't be very popular if you had to understand the inner workings to be able to use it. So the reason that it is so well liked is because the complexity involved with making the phone work is hidden. And what's left available for interaction is an abstracted idea of an iPhone. So here's an example of how that works. There's the blueprint that exists for an iPhone, the very complicated, detailed blueprint of the electrical circuitry and all of the components that go into making an iPhone work. But then, all of that is hidden inside of our class. And instead of exposing all that very complex detail, we give certain behaviors that we deem appropriate or necessary. So rather than allowing the users to be able to directly access circuitry, we give them the ability to power on and power off the iPhone, open, close apps, change the volume level, or turn the location services on and off. And we give certain state elements as available information. The current app that is being used, the volume level currently, and what battery life is left. So then, if we were to instantiate an iPhone based on this blueprint, or create an iPhone based on this blueprint, Then we would not only have the blueprint for the iPhone, but we would have a physical iPhone that we could open an app, and therefore there would be some current app, there would be some volume level, there would be some battery life, and we could interact with it in employing the methods power on, open and close, app, change volume, location on off. And we could create multiple iPhones, all based on this blueprint. This is exactly how objects work in Java. So we write the class file, which is the blueprint, and it hides and contains all of the complexity. But then we leave available an abstracted idea of how this class works. And when we create that object for use in a program, what is actually interacted with is this abstracted notion of our class. So if we were creating the class iPhone, we would write all the code involved, abstract it so that the user didn't have to deal with all the complexity, and then when the user instantiated this iPhone class and created an iPhone object, they would be able to see these data elements, what the current app is, the volume, the battery life, as well as make use of the behaviors written into the class. So a class is the definition or a template or blueprint for an object. It defines what sorts of data the object can store, an object of that particular class can store. So that would be its state information. And it also defines what methods are available for use with that object. So like with the string class, we have the char@at method. So when we have some object which satisfies our class definition, we say that this object instantiates the class. And it becomes an instance of the class. So understand that's what's happening whenever you say new scanner. You are instantiating a scanner object. And this is an instance of an object. So once you've created the object, once you have instantiated the object and stored it in some reference variable, you now have an instance of that class. So this is just like with our iPhone, where we had the blueprint for an iPhone, but then when we instantiated the class, we made an iPhone based on the blueprint. And then we had an instance of an iPhone. Collectively, we refer to the data and the methods which are part of the class to be members of the class. So, as an example, the actual characters that are stored in a string would be members of a class. Or when we are creating an array object, the length field would be a member of the array object. As well as when we have a string object and use the char@at method, the char@at method would also be a member of the class. So any of the data or any of the behaviors that are a part of this class are members of the class. So a bit more nomenclature. All of the methods and data are referred to as members of the class, but the data is referred to as instance variables. So when we have an array object in Java and we make use of the .length field, we are making use of an instance variable. But if we create two different arrays, we create array 1 and array 2, and array 1 has 4 elements while array 2 has 5 elements, and we access the length instance variable of array 1, it should be that we find the value 4. And if we access the instance variable called field that is in array 2, we should get the value 5. That's why they're called instance variables. They are associated with a specific instance of the object. So they are not the same in every object. They may have the same name, but the value they take on will be different in different objects. So the data associated with a particular object is known as instance variables because they are associated with a specific instance. Array 1's field value is 4, but the same instance variable in array 2 has the value 5. This is sort of like having multiple iPhones again. So let's say we have 2 iPhones, both of them are iPhones. However, we can have one with the volume level set at 10 and another with the volume level set at 17. The current volume level is an instance variable, and in iPhone 1, it has the value 10, but in iPhone 2, it has the value 17. So each instantiated object gets its own set of instance variables. So when you go about creating class files, this is the typical process you should follow. First of all, obviously you have to write the class. So each class definition should be in a Java file by itself, and the name of the file should match the name of the class. And obviously the file extension should be .java. The next step is to compile the class. Before a program can make use of this class file that you've written, it must be compiled. So when Java compiles your .java file, the result is a .class file which contains the compiled bytecode. The final step is to write a client program to test your class to see if it provides the functionality that you intended. If your class file that you created exists in the same directory as your client program, then you do not have to use the import statement. However, if this is not the case, you may need to import it just as you do the scanner. So to keep things simple, keep your class files in the same directory as the program that you're writing, which makes use of the class file. So in the majority of the rest of the lecture, we're going to be developing a class called student. And it'll contain the data fields name, age, and GPA. So these are instance variables that we're going to code into this student class. And then the behaviors or the methods that we're going to code will be set name, set GPA, and print student. All of these instance variables and all of these methods are members of the class. Now, programmatically, this is going to be very easy for us to do. The important thing is not that you can type the same things into your development environment that I show you in the lecture. The important thing is that you understand the concept behind creating this student object. So here's the data that we want. Our instance variables will be name, age, and GPA. Name will contain the student's name, the student's age, and the student's GPA, respectively, in each of those variables. Set GPA is going to set the value of the student's GPA to whatever is passed in parameter X. The next method is on a roll. This will return a Boolean value, true or false, for whether or not a student's current GPA is honor roll worthy. And finally, we have print student, which will print the student's information. So this is what it should look like when we're done creating our student class. We should be able to create some variable, some reference variable called S1 of type student, and we should be able to assign it a new student object which has this information. Once we've written our student class so that we have our instance variables and we have our methods, we should be able to instantiate multiple objects so that we have multiple student instances. So we could have one with the name Kanye, age 35, and GPA 2.8, and the methods, which are a part of the class. But we could have another instance, which is Kim, age 34, and GPA 2.9, with the same member methods, but different member instance variables. Okay, so we've created a module called ICA-11.1 for in-class assignment 11.1. we need to put a new Java class into our source file. We'll call it student because that's going to be the name of the class, student.java. Okay, and it automatically gave us the correct name because it knows we have to have the same name for the class that we have for the file. Now, we're not going to put a main function in this. Rather, we're just going to define the instance variables that we want. So we want a string called name. We want an integer called age. And we want a double called GPA. So that's all we're going to put into our student class to begin with. Now let's go ahead and create our client file, and we'll just call it client. And here we will create our main. So now we don't have to import student, remember, because it's in the same directory. So we're okay there. Okay, so remember in our client, or in our student file, our student class, we have 3 instance variables, 3 data fields, but we have no member methods yet. So we won't be able to call any methods, but we will be able to access these fields. So let's write a simple client program that will create 2 student objects and access the instance variables in those objects. So we will say student S1 is equal to new student. And we'll create student S2, also a new student. So understand the syntax. We declare a student type reference variable. So this variable is going to hold the reference to a student object, and we assign it the reference to a newly instantiated student object. So this S1 will contain the reference to an instance of our class student. So let's, inside S1, let's set the name. And inside S1.age, we'll set that to 18. And inside S1.GPA, we will set that to a double value. Let's say the B student, 3.4. Pretty good. Okay, let's do S2.name equals Hannah. And S2.age, she's also 18. And S2.GPA, she's a little smarter, 3.7. Okay. Now, let's print out our student, S1. So we'll say S1.name, and we'll start with a string just so we can tell what's going on. We'll say this student's name is. We can print out this student's name is followed by the student's name. Then we will concatenate another string to the end of this string we've just created. We'll say period, their GPA is colon space plus and then S1.GPA. And we won't print out their name. We'll just print out their GPA. And we're going to copy this and we'll use it to also print out S2. So we'll change S1 to S2. Now let's run this. So it's building. parsing. This student's name is Jake. Their GPA is 3.4. This student's name is Hannah. Their GPA is 3.7. Now, I skipped a step. If you remember, I said you always have to compile your student before you can run or use it in the client class. But what happened was, when I told Java to run the student file, since I'm using this IntelliJ IDE, it knew that I would have to compile student before being able to make use of it in client. So it went ahead and compiled it for me. So we wound up with this student's name is Jake, their GPA is 3.4. The student's name is Hannah, their GPA is 3.7. Pretty useful. Now we can store student information without having to make arrays and trying to remember which student was at which index and which array. In our student class, we have instance variables, but no member methods. And the way that we're setting and getting information in our client is via the dereferencing operator, the dot operator. So to be able to set information, we are directly accessing this instance variable in S1 and setting the information. We do the same thing in S2. And then when we want to access the information, we use the dot operator again. This, in general, is not how we're going to access instance variables. We would prefer to have methods in the class to perform the operations of setting and getting the value stored in instance variables. Here's a mini exercise to test your comprehension. Pause the video and see if you can predict what this code will print out. So let's talk through it. We're going to create a new point object and store the reference in P1, another point object and store a reference to that point object in P2. P1's x value we set to 5. P2's x value we set to twice whatever is stored in P1's x value. So 10 is stored in P2.x. P2.y, we assign the value 10. When we print out P1.x, we will get the value 5. When we print out P1.y, we'll get 0. The reason is because when we create a new object, so we are instantiating this point object, it initializes all of the values to a 0-like value. So integers go to 0, booleans go to false. Any reference variables would be set to null. So 5.0 is printed out by the first statement in the print lines. The second print line statement is going to print out 10. 2 times the x value is 10, and then we store 10 in the y value. So 10, 10. So the correct answer is 3. So now consider the situation where we have a file of student records which begins with a single integer on a line by itself to indicate the number of students in the file, and each record is contained on a single line. So a student record would look like name, age, GPA. Can you think of a way to write a program to read the student's record and then print only the students' names and GPAs to a separate file? One way we could go about doing this would be to create separate, however related, arrays. So an array for student name, an array for student age, and an array for student GPA. Then we could print just the student name and GPA arrays to the file. That would work. And it would look something like this, right? These 3 parallel arrays, one for name, which is a string array, one for age, which is an integer array, and one for GPA, which is a double array. And then we would use the student count as the number of elements for each array, and then we would have some for loop to process in each record. And we'd have to use the next int, next double to read in the values from the file. This will work. We can certainly write our code this way and it will function. However, we can do better. Instead of having these 3 parallel arrays that we have to make sure and index appropriately, let's just create an array of student objects. So since we're going to be using objects, we're going to have to remember to do our 2-phase initialization whenever we're dealing with arrays of objects. So the first phase is going to create the array, and every element of the array is going to have a null pointer. The second phase is going to instantiate an object and assign the reference to that object to each element of the array. This resulting code is going to be a whole lot cleaner and much easier to maintain. The new code would look something like this. We would have our scanner called input to get input from the file, and then we're going to get the first integer in the file, because this first integer is the count, the number of total students. We're going to use that count to create our array. So we declare an array of student objects, and we call this array student info. So this is a reference variable which will hold a reference to an array of student objects. Then we're going to create our array by saying new student, and then notice we're not using parentheses here, we're using brackets because this is creating a new array of student objects, and the total number of elements in this array will be whatever number we read in to student count. So this reference variable will now point to this student array object, but every one of the elements is going to contain a null pointer. So now we have to create objects and assign references to those student objects to each of those elements. So we create a new student object and store it in a reference variable called s, just temporarily. Then we get the name, age, and GPA for this student called s, and then we are going to store the reference, which is in s, in element I of our student info array. So we create the student object, assign a reference to the student object to the variable s, populate all the instance variables, and then store the reference, which is currently in s, in our element I of our student array. Then we will update the value of I by adding 1 and begin to process the next student. So we'll create another student object. So every time this for loop executes, we're creating another student object, storing it in s, getting the next student's information from the file, and then storing the reference to this populated student object in element I.